Hello there, Nareg is here. Again, we're gonna talk about how to study the variation of rational functions, but in this case, I'm gonna take an example where we were gonna discuss about the oblique asymptote. So it will be a function where the numerator has a degree, 1 degree higher than the denominator. So let's first start by talking about the steps that we're going to follow in order to study the rational function. And these steps are actually the steps that you can use in order to study almost any rational functions. Again, we're going to define a rational function. So for a rational function, it could be written as f of x is equal to p of x over q of x, where p of x represents a certain polynomial and q of x represents also a certain polynomial. So whenever you have this form, you're already talking about a rational function. Previously we had been we were talking about a rational function in the form of ax plus b over cx plus d. Now we're going to take another example where the numerator is 1 degree higher than the denominator, and of course we're going to discuss about the oblique asymptote. But let's first check about the steps. The first step that we should follow is to talk about the domain of definition. The second step is to calculate the limits. Now, after calculating the limits, we're going to be able to talk about the asymptotes. Now, in this case, whenever we have a rational function, it's very possible to have vertical asymptote or horizontal or even oblique. Once you have calculated the limits, you can go to calculate the derivative. From the derivative, you will be able to do your table of variation. Later, the fourth step is to choose some particular points. Of course, these points are going to help you in order to draw the curve, particular points. Fifth step is to talk about the symmetry. If there is a symmetry, we can talk about the symmetry, or we can leave the symmetry as the last step. After drawing again, we're going to talk about the symmetry. As for the sixth step is to draw the curve, actually. Alright, so I'm going to take an example and we're going to study this new rational function. Our example will be f of x is equal to x squared minus x plus 1 over x. As you can see, my function, of course, it's a rational. I have the numerator 1 degree higher than the denominator, so possibly I will be able to get an oblique asymptote. But let's first go through the steps. The first one is to talk about the domain of definition. In this case, your domain of definition is from minus infinity to 0 union from 0 to plus infinity. Because x, which is the denominator, should be different than 0. So I will have to exclude this value, which is 0. Once I have done the domain of definition, I can directly talk about the limits. So the limit when x tends towards minus infinity for x squared minus x plus 1 over x, it's the limit of x tending towards minus infinity of x squared over x. I can choose the highest monomial over the highest monomial. I can simplify and I will have minus infinity. Again, the limit when x tends towards plus infinity of x squared minus x plus 1 over x is equal to the limit of x tending towards plus infinity of x squared over x. Once we simplify, we will have x, so we replace by plus infinity, the result will be plus infinity. The limit when x tends towards 0 minus for x squared minus x plus 1 over x. Once I replace it, I will have 0 minus 0 plus 1, it will be plus 1 over 0 minus. So it's a negative value, 1 over 0 minus, it's minus infinity. And finally, the limit when x tends towards 0 plus of the same function, of course, x squared minus x plus 1 over x, it's plus 1 over 0 plus. So in this case, it will be plus infinity. Now, since we were able to find the limit for x tending towards 0 plus or 0 minus plus or minus infinity, I can deduce that x is equal to 0 is a vertical asymptote. X is equal to 0 is a vertical asymptote. After studying the limits, I can go and study the derivative, calculate the derivative. So my function is x squared minus x plus 1 over x this is in the form of u over v, so I'm going to do it in another color. It says directly f of x, which is u over v. And of course, the derivative will be f prime of x u prime v minus u v prime over v squared. So we have u is equal to x squared minus x plus 1. Once we calculate the derivative u prime, it will be 2x minus 1. V is equal to x, so v prime is equal to 1. So f prime of x in this case, f prime of x is equal to 2x minus 1 times x minus x squared plus x plus 1 minus 1 over x to the power of 2. So I will have to arrange it. 2x squared minus x squared plus x minus 1 over x squared. So it will be f prime of x to x squared minus 1 over x squared. Now x squared minus 1, of course you can factorize it as x minus 1 times x plus 1. So after calculating f prime of x, we should go through the table of variation. So I should study the sign of f prime of x. Once I'm going to study the sign of f prime of x, I should say f prime of x is equal to 0, which means x squared minus 1 over x squared is equal to 0. Again, which means x squared minus 1 is equal to 0. X minus 1 times x plus 1 is equal to 0. The values will be x is equal to 1, x is equal to minus 1. And directly I will be able to do the table of variation, x going from minus infinity to plus infinity, passing by the values minus 1, 0, and 1. Now, the numerator is x squared minus 1, denominator is x squared. I can deduce f prime of x, and finally the variation of f of x. X squared minus 1, it will be 0, 0. For x is equal to 0, it's a shaded part. It's a value that we have already rejected. It's a discontinuous part. So x squared minus 1, 0, 0. Between these two zeros, it's the opposite sign of the coefficient of x squared. So it's negative, negative. Outside it will be positive, positive. X squared, it will be 0 for 0, but it's shaded, just like we just mentioned. So positive, 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 and positive. F prime of x will be plus 0 minus 0 plus. F of x will be increasing, decreasing, decreasing again, and increasing. Now we can of course add the limits. For minus infinity it was minus infinity, for plus infinity it was plus infinity, for 0 minus it was minus infinity, so I'm going to add the value. So in this case it will be minus infinity, and for 0 plus it was plus infinity. Okay, now that we have our table of variation, of course we can find the values of f of minus 1 or f of 1. It will be the minimum and the maximum, since we have extra mums in this case. So there is f of minus 1 and f of 1. We can calculate them. So I'm gonna choose the particular points, plus I'm gonna calculate f minus 1, f of 1, and then draw the curve. So we have f of x is equal to x squared minus x plus 1 over x. F of 1 will be equal to 1 over 1, that's 1. F of minus 1 will be equal to 3 over minus 1 minus 3. F of 2, let's say, will be 4 plus 1, 5 minus 2, 3 over 2. F of minus 2 F of minus 2, it will be 4 plus 2 plus 1, 7 over minus 2 minus 7 over 2. Alright, since I have these values, I can draw my curve. I will have to draw my curve. But first, I will have to talk about the oblique asymptote. How are we supposed to find the oblique asymptote? There is a certain method. So, in order to find the oblique asymptote, we will have to divide x squared minus x plus 1 divided by x. This is how I will be able to find the equation of the oblique asymptote. X times x, x squared. So in this case I will have to change the sign, minus, so I will have 0, and then minus x plus 1, and I'm gonna multiply by minus 1. It will be minus x. Again, I will have to change the sign since I'm doing a subtraction. So what remains is finally 1. Alright. Now, what you can actually deduce from this division is that x minus 1 will be your oblique asymptote. X minus 1 will be the oblique asymptote. This is how you find the equation of your oblique asymptote. How are you supposed to verify that this is actually your oblique asymptote? Is very simple. You will have to say that the limit of x whenever it tends to plus or minus infinity of the function, which is x squared minus x plus 1 over x, minus your equation x minus 1 is it equal to 0. That's what we should verify. We should take the function and the curve and the line y is equal to x minus 1. We check the difference between the function minus the equation of the line, and whenever the limit for x tending towards plus or minus infinity gives me 0, I can simply say that yes, x minus 1 is actually the equation of the oblique asymptote. So first I'm gonna calculate x squared minus x plus 1 over x minus x plus 1. I can choose a common denominator, x, It will be x squared minus x plus 1 minus x squared and plus x. So I will have 1 over x. The limit of x tending towards minus infinity of 1 over x is actually 1 over minus infinity, and it's 0 minus. The same thing, limit when x tends towards plus infinity of 1 over x, it's again 1 over plus infinity, it's 0 plus. So I can deduce that the equation y is equal to x minus 1 is an oblique asymptote. And right now, whenever I'm going to draw my curve, the first thing that I should be doing is to represent my oblique asymptote, my vertical asymptote. I will have them on my graph, and then I will be able to have an idea about the position of my curve. So let's start by doing the curve. So we have y is equal to x minus 1. So for x and y, x is equal to 0, y is equal to minus 1, x is equal to minus 2, y is equal to minus 3, x is equal to 2, y is equal to 1. So the first thing that I will be doing is to represent my line, the oblique asymptote. For 0 it's minus 1, for minus 2 it's minus 3, for 2 it's 1. So this is my oblique asymptote. My vertical asymptote was x is equal to 0, so it's the axis of ordinates. X is equal to 0. And then I will have my curve. So what about my curve? Let's check the values. For f of 1 is 1, f of 1 is 1, 1 is 1, and this is actually a minimum. This is a minimum, yes. F of minus 1 is minus 3, f of minus 1 is minus 3, f of 2 is 3 over 2, f of 2 is 3 over 2, so it's somewhere here. F of minus 2 is minus 7 over 2, so it's somewhere here. And my curve will be taking this shape. It comes from minus infinity towards the maximum, and then towards minus infinity, and then from plus infinity towards this minimum, and it will tend towards plus infinity. This is the shape of my curve. Now, once you have represented your curve, you have drawn your curve, we can also talk about the symmetry. In this case, we do have a certain symmetry. Is actually a central point, which is this point. It's the intersection of the asymptotes, which will give me the center of symmetry. So the value, which is 0 minus 1, actually, let's say this is the point I, 0 minus 1, is the center of symmetry. It's the intersection of the asymptotes. Now, how are we supposed to verify that this point I with the coordinate 0 minus 1 is the center of symmetry? It's very easy. You're gonna have to go through the formula. So is I 0 minus 1 the center of symmetry? This is what are we going to check right now to verify. The formula is f of 2a minus x plus f of x is it equal to 2b. Now, a is the abscissa of this particular point. In this case, it's 0, and b is minus 1. So f of 2 times 0 minus x plus f of x is it equal to 2 times 1. So f of 0 minus x plus f of x is it equal to 2. F of minus x plus f of x is it equal to 2. In this case, I will have to take my function, and whenever I have a certain value of x, whenever I find x, I will have to replace it by minus x. So I will have minus x to the power of 2 minus x plus 1 over minus x Alright, I'm gonna write it down on a new page, it's better. So minus x to the power of 2 minus x plus 1 over minus x plus x squared minus x plus 1 over x is it equal to 2. So x squared plus x plus 1 over minus x plus x squared minus x plus 1 over x is it equal to 2. So I can say that it's minus x squared minus x minus 1 over x plus x squared minus x plus 1 over x. Will it be equal to 2? As you can see, minus x squared plus x squared plus 1 minus 1, so I will have minus 2x. So I just have to say that minus 2x over x is it equal to minus 2? In this case it will be minus 2 minus 2 minus 2. Since we have the ordinate of b is minus 1, well, minus 1 minus 2 minus 2. So yes, I can say that minus 2 is actually equal to minus 2 is verified. So I, which has the ordinate 0 minus 1, coordinate 0 minus 1, is a center of symmetry. Okay. So yeah, that's it. We were able to discuss about our function. We were able to I'm gonna go through my function from the beginning. So domain of definition, we have a value which is excluded for x is equal to 0. This value is an excluded value. Then the limits, from the limits I was able to find a vertical asymptote, f prime of x, which would help me to do the table of variation. From table of variation, of course, I can go and choose some particular points. Plus, I was able to check, I was able to find actually the equation of my oblique asymptote. And right now I know how to verify whenever this oblique asymptote is actually the right equation. So you'll have to go through the limit once again and check the difference between your curve and your line. Whenever x tending towards plus or minus infinity, is it really giving me a value which is close to 0? Once we have done this, we can of course draw the curve. But the first thing that you should be doing is to represent your asymptotes, the vertical, the oblique asymptote in this case, since we do not have horizontal. Once you have done this, you can of course choose your particular points and then draw the curve. The intersection of your asymptotes will give you the center of symmetry, and for the center of symmetry it's very easy. You can actually use the formula f of 2a minus x plus f of x is it equal to 2b. Once you have verified this, you can say that your point with which we chose in this case I 0 minus 1 is actually a center of symmetry. That's all for this function. I'm gonna do another video about a rational function again, but in this case I'm gonna choose a function where the numerator is 1 degree less than the denominator. So why not? You can subscribe to my channel. You'll be notified whenever I upload new videos, new material, and I can also share my Instagram and Facebook account in case you have any question, or you can simply leave a comment. That's all for today. I hope you enjoyed. See you next time.